Hello friends, welcome back. In this video we will solve some more questions of differentiability. So the first question is, we have to discuss the differentiability of this function fx at x is equal to 0. So the given function fx is equal to x mod x. So this function fx will be differentiable at x is equal to 0 if its left hand derivative is equal to right hand derivative. So first of all, I'll find its left hand derivative. So its left hand derivative is limit x tends to 0 minus fx minus f0 upon x minus 0, and it is equal to limit h tends to 0 f0 minus h minus f0 upon minus h. So it will be equal to limit h tends to 0, so f0 minus h, right? It will be 0 minus h into mod 0 minus h minus f0. It will be 0 upon minus h. You can see the definition of function fx. According to the definition of the function fx, f0 will be 0. Now it will be equal to this, right? This minus h will cancel this minus h, and limit h tends to 0, h will be equal to 0. So the left hand derivative is 0. Now we have to find the right hand derivative of this function fx at x is equal to 0. So right hand derivative is limit h tends to 0 f0 plus h minus f0 upon h, and it will be equal to, so what will be the f0 plus h? It is 0 plus h mod 0 plus h, right? Minus f0, it is 0. So it will be limit h tends to 0, h square upon h is equal to limit h tends to 0, h is equal to 0. So here you can see that both left hand derivative and right hand derivative of this function fx at x is equal to 0 are equal. They both are equal to 0. Hence this function fx, since left hand derivative is equal to right hand derivative, hence this function fx is differentiable at x is equal to 0. Okay, now let us do another question. So the next question is, this is the function fx. So this is the definition of this function fx. This function fx is equal to 0 when x is equal to 0. Otherwise this function fx is equal to this. x into e raised to power minus 1 upon mod x plus 1 upon x. So we have to discuss its differentiability at x is equal to 0. We need to check whether this function fx is differentiable at x is equal to 0 or not. So for that purpose, again what I need to do, I need to find its left hand derivative. I need to find the left hand derivative of this function fx at x is equal to 0. So here it will be limit h tends to 0 f 0 minus h minus f0 upon minus h. This is the left hand derivative of this function fx at x is equal to 0. Now it is equal to limit h tends to 0. So what is f0 minus h? So here you can see that when you compare it with this with function fx, x is less than 0, and here x is not equal to 0. So this definition of fx will be used, right? So it will be 0 minus h e raised to power minus 1 upon mod 0 minus h plus 1 upon simply 0 minus h, right, minus f0. So f0 will be what? It will be simply 0 according to this definition of function fx. When x is 0, fx is 0 upon minus h. Limit h tends to 0. So 0 minus h is minus h. E raised to power minus 1 upon 0 minus h, it will be 1 upon h, and 1 upon 0 minus h is this, minus 1 upon h. So this minus h will cancel this minus h. So it will be limit h tends to 0, e raised to power, it will be 0. 1 upon h minus 1 upon h, it is what? 0. So it will be equal to 1. Similarly, I will find right hand derivative, right? So left hand derivative is 1. So what would be the right hand derivative? It is limit h tends to 0 f0 plus h minus f0 upon h, and it will be equal to zero plus h e raised to power minus 1 upon mod 0 plus h plus 1 upon 0 plus h. See, what is f0? f0 will be equal to 0 according to the definition of function fx. So it will be equal to limit h tends to 0 h upon h e raised to power minus 2 upon h. This h will cancel this h, right? Now it will be e raised to power what? It will be equal to e raised to power minus infinity, right? Now e raised to power minus infinity will be equal to 1 upon e raised to power infinity, right? And this value will be approximately equal to 0. So here the right hand derivative will be 0, right? And what the left hand derivative is? Left hand derivative is 1. So here you can see that right hand derivative is not equal to left hand derivative. Therefore, this function f(x) is not differentiable at x is equal to 0.